Okay, welcome back to another exciting video talking about biochemistry. So in this one, what we're going to do is we're going to talk about chemical reactions. So in the last one, what we went over is we went over bonds and molecules and compounds. What a chemical reaction is it either creates bonds or it breaks bonds. So a reaction, create or destroy chemical bonds. Okay? In order for a chemical reaction to occur, we need energy. And the energy that is required to actually get a reaction to occur is called the activation energy. Right. So if we look, so we can graph this out, and what we would see is, so this would be the energy, and this would be the progress of the reaction. What we're going to see is something that looks like this. And what we're seeing here, this upstroke, all of this area in here, this is the activation energy. Now, what you start out in the beginning of reaction, what you're trying to work on, these are called reactants. And once you have done the reaction, what you have are called the products. The products itself. Now, reactants won't react with each other until you have met an activation energy threshold. Once you meet the activation energy, then the reaction will occur, and what we get later are the products of the reaction. Okay? So to summarize, a chemical reaction is a reaction that will create or destroy chemical bonds. Okay? What we're trying to work on in a chemical reaction is called reactants. What we're trying to produce from a chemical reaction are called products. Okay? No reaction will occur unless we get over the initial activation energy of the reaction itself. Now what we're going to do is we're going to talk about the common reaction types that you need to know about in anatomy and physiology course. So the first of these, so let's do types of reactions. Okay, so number one is a synthesis reaction. Is a synthesis reaction. And what this reaction does is it will create a chemical bond. Okay. And the generic form of this is the reactants A plus B. So A could be any molecule, or it could be any atom or any compound, and B could be a different molecule, chemical or compound, and what we do is react it and it will form a new molecule or compound called AB. So a real-time example of this would be, let's make water. Let's make water. So in order to make water, we need two hydrogen molecules. So remember the notation. So we have two here. This two here means we have two hydrogens, and this two out here means we have 4 hydrogens total. And if we react that with 2 oxygen molecules, what we're going to get is we are going to get 2 water molecules. Now, the important thing to note when you're looking at these chemical reactions is that mass has to be conserved. You have to conserve mass. So I can't have 4 hydrogens in the reactants. Okay, so this is 4 hydrogens. I can't have 4 hydrogens over here, and I can't have 2 oxygens over here. on the reactant side, I have to have the same number of hydrogens and I have to have the same number of oxygens in the product side. I just can't make poof, the matter disappear, so it has to be conserved. Okay, but this here is a synthesis. This is a synthesis reaction because what I'm doing is I am creating new chemical bonds. So basically what I'm doing here is I am making 2 water molecules. I'm making 2 water molecules. That is a synthesis reaction. Now, a special case of the synthesis reaction is called the dehydration synthesis. Dehydration. So D means to undo, and hydration means water. Okay, when you're hydrated, it is water. Hydro is water. So the dehydration water is to basically take out water. This is also called a condensation reaction. And basically what I'm going to be doing is you're going to combine 2 larger molecules together. And in doing this, you just have to take a water out. You have to take a water out. And we'll go over this more when we start talking about carbohydrates. Carbohydrates or proteins or lipids. Because they all use dehydration synthesis to make larger ones. So what we have, for example, we have fructose, which is a sugar, plus galactose, which is another type of sugar. So these are what's called simple sugars. They're single sugars, okay? And if you react them together, and in doing so, you remove water, you get a substance called sucrose and water. Sucrose and water. And again, right now, you don't have to know the workings of it when we talk about carbohydrates. I will go and show you where we remove the water to make them larger. But right now, all you need to know is dehydration synthesis. I combine 2 smaller molecules or compounds together by removing a water from them. I take a water out. Okay. So sucrose, this is table sugar. Okay, you all know that. That's the sugar that you put in cakes and make things sweet. Put in your coffee. That's what it is. Sucrose is a large sugar combined from 2 smaller sugars. The smaller sugars being fructose and galactose. Okay, so a synthesis reaction creates chemical bonds. Okay, by combining 2 smaller compounds. A special case of this is called a dehydration synthesis, where we make a larger molecule of 2 smallers by removing water. Okay, so if we have a synthesis reaction, which creates, the next one is a decomposition reaction. The decomposition reaction. And what this does is this breaks chemical bonds. And that's its job. We're going to break down chemical bonds. Okay. So in our product side, basically a decomposition is going to be the reverse of a synthesis reaction. So if I have generic product AB, and I do some chemical energy work on it, what I'm going to get is resultant A and B. So what I've done is I've gone and chopped this. I've chopped it. I've chopped that bond holding A and B together, and now they exist separately as A and B. Okay, a real world example of this is if I had 2 water molecules, and I break them, they would form the gases, hydrogen and oxygen. Hydrogen and oxygen itself. So I have broken the bonds that hold the hydrogen and oxygen together in order to make the individual compounds. A special case of decomposition reaction is called hydrolysis. Okay, so now if you've ever taken a medical terminology class, you know that lysis means to break, and hydro means water. Now, if you apply your medical terminology, you'd be like, this is water breaking, I'm going to break water. Technically, yes, that's 100% if you want to use the rote definition of this. But we use hydrolysis, meaning I'm going to take the water and I'm going to use it to break I'm going to use it to break a larger molecule into two smaller molecules. Okay, hydrolysis is the exact opposite of a dehydration synthesis. So where we had sucrose before, where we made sucrose from fructose and galactose, we can take sucrose and we can add water to it to make fructose and galactose. Okay, and this is commonly how your body breaks down larger molecules. It's called hydrolysis reactions. So the reactant would be sucrose. Okay, and if I add water to it, what I'm going to get is fructose and galactose. Okay, I don't want to put the water there, so I'm going to erase this. Sucrose plus water is going to give me fructose and galactose. Now you may ask, well, wait, where did the water go? Because you just said matter has to be conserved. Part of the water will be added there, part of the water will be added there. So I'm actually conserving the mass, even though you don't actually see it. Okay, so don't worry about that. It is there. Okay, so we have a synthesis reaction, which will create chemical bonds. So I'll take two smallers and it'll make a larger molecule. Special case of that is dehydration synthesis. Then I have a decomposition, which will break them. It'll take a larger product and make two smaller reactants. A special case of that is hydrolysis. Now there are two other types of reactions, not nearly as important as synthesis and decomposition. For me, for this class, you have to know synthesis and decomposition like the backs of your hands, but I'm going to put these other two in for completeness. Okay, and there's still more outside of this one, but these are the big four. Okay, so the next one we have are called exchange reactions. Okay, and so basically what this is a combo decomposition and synthesis. So I'm going to be breaking products down, and then I'm going to be rearranging them into two. So I'm going to be breaking reactants down, and I'm going to be rearranging them into new products. Okay. So the generic form would be like AB plus CD, generic. Through the chemical, I'm going to make AD plus BC. Okay. So what I've done is I've taken and I've just rearranged the molecules a little bit. An example of this would be a nice acid-base reaction. So if you have sodium hydroxide, NaOH, that's sodium hydroxide, and and hydrochloric acid, HCl, mix them together, you're going to get sodium chloride plus H2O plus water. So what I've done here is you take the sodium hydroxide and I have combined it with the chloride here. See, chloride and the sodium. And then I have actually let me erase that red marker on here. This chloride right here. And then for the water portion, I have taken this hydroxide and that hydrogen, and I have combined them to make water. So that is the exchange. So you can see here I've broken them apart, which is a decomposition, and then I have combined them later, which is a synthesis reaction. Okay? And then finally we have what's called the reversible. reversible reactions, which actually is the majority of all reactions. Okay? So basically reversible means it can go both directions. So if I have reactant AB, okay, and it forms A and B can also go back this way and make AB. Okay. Now there's a point at which they don't seem to move, and that is called equilibrium. Equilibrium is where the balance of A and B and A plus B are pretty much equal. So then that's equilibrium, where the reaction doesn't look like it's moving back and forth. You know, it looks like it stopped. But reversibles do happen in both directions. A real life scenario for this one is H2O. It likes to bounce back between two forms, H plus OH negative. That's what water likes to bounce back between these two. So that is a reversible reaction as well. Okay, so those are the big four. The ones I definitely want you to remember are synthesis reactions and decomposition reactions. And we will look at those more in detail when we actually talk about our organic molecules. Okay, that's all I have for this one. Have a great rest of the day.